press. And okay, so sensitivity review. So it's not only the UK that implements freedom of information laws. There are in fact over 100 countries that implement such laws. But the documents may contain sensitive information, such as personal or confidential information. So if you're going to transfer the documents to the archive, so it should be publicly archived, you first have to identify, you have to manually review the documents to identify any sensitive information. So this sensitivity review process fits within a sort of larger public records transfer process. So this is in the particularly related to the UK, but many other countries have a similar sort of process in place. So first off, we've got selection and appraisal, which means that you have to identify any records, documents, they refer to them as records, any records that are of public interest or historical value. Once you've selected those documents, these are the documents that should be transferred to the public archives. They must first be sensitivity reviewed, and then after the sensitivity review, that's when they go into the public domain. In the case of the UK, that's by transferring them to the National Archives, firstly for permanent preservation, but also for open presentation. In other words, anyone these days can go to the National Archives website and search these documents and find any information that's in them. So if there is sensitive information that accidentally gets out, it can have detrimental consequences for whoever the information is related to. Okay, so how has this process changed over the years? Traditionally, all documents were physical documents, which were stored in files, in large vaults, and pieces of paper. Someone would have to go through these documents individually and read all the documents and mark out any sensitivities that were on them. They were then transferred again physically to large storage containers within the National Archives. And anyone who wanted to actually come and view the documents had to physically go to the National Archives and search through their archival records in order to be able to try and find the information that they were interested in. However, in the era of born digital documents, we now have sort of large, often unstructured collections of digital files, which are stored on hard drives and can be in lots of disparate hard drives, which are disconnected, which are not had a very sophisticated filing system when they were first introduced. The reviewers, sensitivity reviewers, are typically retired diplomats and people who had extensive experiences of the potential sensitivities at the time of the document's creation. So that would be 20 or 30 years ago. So in other words, the reviewers at this period in time are not generally used to reviewing digital documents and through digital technology. So this is a new experience for them that they're trying to get to grips with. Now, when we preserve the information, it is just bits stored in servers. It can be much easier organized. You can obviously index all this information, and you can easily create search engines, which enables users to come to the National Archives website and just search these records. So it's much easier. It's much more difficult for the reviewers to actually do the sensitivity review and find the documents that relate to each other and what sensitivities might be. And it's much easier for users to come and search the documents and find any potential sensitivities that may accidentally have been released. So our work focuses on this component of this transfer process, sensitivity review. And that's what I'm going to talk about in the rest of the presentation. Okay, so just a brief look at the actual sensitivity review process. We've got this large collection of unstructured collection of documents. In those large collections, there may be some documents that have sensitivities. A reviewer has to review all these documents in turn and mark for each document that contains a sensitive bit of sensitive information. They have to actually identify the document itself, and mark in the document which of the pieces of text within that document are actually the sensitive information. Okay, so what is our vision? Our vision is to assist the human reviewers. So we're not trying to take the human reviewers out of the loop. We're not trying to replace the humans at all, but we're trying to automatically predict the sensitivities within the documents based on historical and recently judged documents, so that we can provide the reviewers with useful information such as predictions of sensitivities, and we could also prioritize which documents should be reviewed at a particular time to make things easier for any particular context. So in doing this, we are aiming to increase the speed and accuracy of manual review. And what that would lead to is that the number of documents that can be open to the public would be increased, because there's a finite amount of reviewing resources and there's a finite time to actually get the reviewing done. So our vision is to increase the accuracy and speed of the review so that we can have more documents released to the public. Okay, so all of the work that we will look at in this presentation particularly focuses on two exemptions to the Freedom of Information Act 2000. So exemption 27 is international relations. So it says here insulting remarks about a leader, but that's just one example. It's much, much more broader than that. It can be, accusing one country accusing another country of misuse of the diplomatic bag. It could be any information that's been supplied in confidence. So it might be someone informing an embassy about something that's happening in a country. That information goes back to central UK government. Eventually that has to get released to the public. And exemption 40 is personal information. So this actually is more nuanced and broader than personal data. It can be any sort of conversations about religious beliefs or employment history, and sort of crime, military service, things like that. So these exemptions are representative of the most frequent sensitivities in the UK government documents. So 92% of paper records, so documents and photographs and stuff like that, that were closed, i.e. were not released between, I think 2005 and 2014 were closed due to personal or national interest sensitivities. Okay, so I briefly sort of mentioned this in the start, but we have a framework for our vision, and it consists of three parts. First part is what we refer to as offline learning. So we want to be able to identify the features of sensitivity that enable us to automatically predict if a document contains any sensitive information. Having done that, we want to create an active learning environment where we can learn from reviewers and the feedback that the reviewers provide. So this is a sort of two-way process. We want the classifiers or the search systems or whatever to be able to learn from the actions of the reviewers. So when they're marking documents as sensitive or not sensitive, we want to be able to feed that into the model and learn from that. But we also want the classifiers to be able to provide the reviewers with useful information so that we can increase the speed and accuracy and openness of the review. So this is, so this is a continuous process that we want to continually enhance the model. So basically, the review process is labor intensive and time consuming, and we want to be able to reduce the workload or the cognitive load on the reviewer. And in order to be able to do that, we need to be able to learn from what the reviewer is doing. Okay, so that provided a wee bit of background into the task. And now I'll just talk about a bit of work that we've done for each of the three components of the system: offline learning, active learning, and decision support, before having just a little mention of our ongoing work at the end. Okay, so context-dependent sensitivity. So this, like many sensitivities, are they're a result of the context that the information appears in. So it may be who has written the information, what the information is about, typically what it's saying about it, or who said it. But often before reviewing a collection of documents, we do not know which text is likely to be sensitive. In this example, here we can see that it's the combination of who said it, what they said, when they said it, and who they were talking about, that putting all this information together makes this made up example a piece of sensitive text. So you've got to be able to learn to identify the particular contexts that might be representative or indicative of particular types of sensitivity. So these sorts of sensitivities often share similar grammatical structures or relations between terms that we can use to develop learned approaches for sensitivity classification. And this slide, I'm sure, will be very sort of familiar to all of you, or what it's saying, but really what it's saying is that, within the documents, there's lots of different things that we can use to try and infer what particular contexts are. So we can identify entities in the document, we can use things like parts of speech, the structure of the documents itself, type of syntax. And obviously, in order to learn classifiers, we need to be able to show the classifier lots of examples of sensitive and non-sensitive information. How can we do this? We have a reviewer who is doing their job. They're reading the documents. We can get them to mark the sensitivities in the documents. We can then do some processing and identify the particular features which are useful or frequent in identifying particular contexts of interest. So the first work that we're sort of looking at is a paper that we published in ECIR in 2017. And what we thought of is we'd like to be able to automatically identify features that are indicative of contexts that are likely to be sensitive. And we know that embeddings can be effective at capturing such contexts. So in an embedding space, similar words appear in close to each other, and the directionality between the words can give some indication of the relationship between the words. So what we really want to do is we want to learn from the word representations, and we want to use this contextual information to try and build up a rich representation of the information and the context. So what we can do is we can combine the text classification approach, where you just use the distribution of the term features by one-hot encoding, with the dense representation that is good at capturing these contexts. And by combining these to make document representations, we can use these sort of contextual document representations to train the classifiers. So then when we did this, we basically just wanted to know, does this work? So we had two basic research questions. How effective is text classification? And are semantic word embedding features more effective for classifying sensitivity? So we find that text classification on its own achieved it performed markedly better than random. It achieved 0.67 back. So we use back balanced accuracy because the sensitivity is very rare in collections. I think in the collections that we were using at the time, it was about 10%. In reality, it's closer to sort of, 2 or 3% at most. But we found that adding the semantic features resulted in a significant improvements. We could identify roughly sort of 10% more sensitive documents than just using text classification alone. So that was a good start. At this stage, we were still quite early in our research. We didn't really know whether this was possible. So we started this work, I think, in 2016, 17. And the National Archives approached us and said, could you find a solution to this? Is this possible? And, we didn't really know. So we started with a basic text classification approach, and we thought, right, how can we improve it? And this was a very promising start. But then we started to think, well, okay, we can potentially learn offline, but all of any collection that you go to sensitivity review, you don't really know what the sensitivities are in it at the start. So we want to be able to quickly learn to identify what sensitivities are in a particular collection. So e-discovery could potentially be adapted for sensitivity review. For those of you who are familiar with e-discovery, the typical process, there's a human and IR system working together. You might have some keyword search terms and an active learning classifier, which combine to be able to find information that's relevant to a particular legal case. So sensitivity is more akin to privilege, in that you're identifying the information that should not be released. The difference is that in sensitivity review, we don't really have this first sort of part of the system. We can't have a search system to start looking for the sensitivities because we don't know what they are. So the question is, how can we quickly learn to identify sensitivities when we don't know what the sensitivities are? So what's the process that we've got? We've got a document collection, and we've got an active learning classifier. We've got an interface to the reviewer. At the start of the process, all of the documents are unlabeled. We don't know anything about the documents. We want to select some documents that would help the classifier quickly learn. So we present these documents to the reviewer. We have the reviewer annotate the documents as to what the sensitivities are. We can feed these labels back into the document collection. It means we're starting to build up a labeled set, which we can then start to use to train the classifier, which in turn provides more information to the active learning part of the classifier, so that we can start to learn to identify the sensitivities quickly. So that's quite a basic sort of active learning cycle. So our main sort of finding was that if we record the individual features that the reviewer annotates, and we have a process whereby at each iteration of the active learning cycle, we calculate the information gain on this pool of features, that the term features that the reviewer has collected, then by adding these term features in the high information gain term features into the document representations, we can actually improve the speed that the classifier learns to review. So here, looking at the results, we would like to be up here in the top right-hand corner. On the x-axis, we have the reviewer effort. So that's the number of documents that have to be reviewed in order for the classifier to reach a certain level of effectiveness. And the level of effectiveness is on the y-axis in balanced accuracy. So we want to be a very high balanced accuracy, having reviewed very few documents. So we tried 3 different active learning strategies from the literature that are well known: entropy, margin, and utility. So we found that margin and utility start to identify sensitivities with less reviewing effort, and margin performs best overall. So here we're seeing that at around 1,500 documents, the classifier is reaching its most effective effectiveness. So what happens when we integrate these high information gain annotation features? All of the approaches start to identify sensitive documents quicker. But importantly, the classifier now achieves its peak performance significantly quicker. So it's only 820 documents that are required to reach the best effectiveness compared to around 1500 without these features. So these experiments were run as a sort of simulation over stratified samples of 2,500 documents. And here, we see the average over the over all of the samples. Excuse me. So the sort of takeaway message here is that by using the context that the reviewer is providing us, and having some processing in the back to identify, out of all this information the reviewer is giving us, what is the most important or most salient information to identify the particular sensitivities in this collection, then we can learn what the sensitivities are much quicker. Okay, so active learning conclusion. So by having sensitivity reviewers annotate or redact sensitive text in the document as they review, the effectiveness of the sensitivity declarator can be continuously enhanced, and therefore adapting to unknown sensitivities within a collection significantly faster. And we managed to reduce the effort that was required by the reviewer, the reviewing effort, by 51% just by integrating this additional context into the sensitivity classifier. Okay, so that's the basic process of what we're wanting to do with the active learning. One thing that's worth noting about active learning strategy is that the active learning strategy presents the documents to the reviewer that are most useful for the classifier to learn. But the reviewer themselves might prefer a different presentation strategy. For example, they may want to review documents in chronological order, or they may want to review batches of or clusters of related documents. Often sensitivities may not become apparent until you see information which is in other documents. And sort of putting this information from multiple documents together can enable the reviewer to have a better insight into the potential sensitivities. This is often referred to as mosaicing classification. So we've done some work on investigating when we should switch presentation strategies. When do you want to stop active learning and switch to a different presentation strategy for the reviewer? So this is ongoing work. There's definitely a lot of, it's an open question basically, but what we've found in our work so far is that whenever a classifier makes a prediction, it has a confidence level or a probability associated with it. And just by monitoring the confidence of the classifier at every level, every iteration of the active learning cycle, once the classifier's confidence stops increasing for a certain number of iterations, it can be a good indication that it can be time to stop the active learning and switch to another strategy. And that obviously feeds into assisting the reviewer. We want to be able to help the reviewer to do their job within the context that they want to do it in, that is most useful for them to do it in, because that is the main aim and objective of the entire process, So that brings us on to the decision support part of the framework. We want to be able to assist the human sensitivity reviewers to do their task more efficiently and hopefully more effectively or accurately too. Okay, so the last thing last bit of work that I'm going to speak about is a user study that we have conducted. We've got this hypothesis at the time when we started it, that sensitivity classification predictions can provide human reviewers with useful information about potential sensitivities. And as I said previously, we want to be able to help the reviewers to be more accurate and quicker in their review process. So they're reviewing documents, they've got to say which ones are sensitive, which ones are not sensitive. So we want to conduct a user study to make sure that what we're doing in providing them this information about potential sensitivities or sensitivity predictions is actually useful and it's helpful and it's doing what we intend it to do. It's one thing being able to sort of predict sensitivities, but if it doesn't actually help the user in the end to actually do their job better, then there's more work to be done. So what we really wanted to know in the user study is, does providing the reviewers with sensitivity predictions reduce the amount of time that's required to accurately sensitivity review the collection of documents? And how does the accuracy and confidence of the classifier affect the reviews? So I haven't got time to go into the entire user study, but I'm just going to highlight a few couple of takeaway messages from it. So first off, to give you a bit of context of how the study was set up. So all of it's a within subject experimental design. So all of the reviewers reviewed each of the conditions in the study. So a condition is a particular treatment. So we've got 3 batches of documents. Each batch of documents has a particular treatment, and the treatment is the effectiveness of the classifier's predictions. So we've got none, medium, and perfect. The none just means that the reviewers were not shown any classification predictions at all. Medium means that the classification predictions were of an accuracy of 0.7 back, which is about the same as the accuracy of the level of the classifiers that were developed at the time and published. And then we've got a perfect classifier to see, if they were given perfect predictions, how well would they do? So the perfect predictions, they were, I'll say a bit more about them in a second, but basically you have expert reviewers which create a ground truth first, and then the expert ground truth is not given predictions, they're just doing their job. And then in the study, we're using the same documents that have already been reviewed, and we want to see if the reviews of this user study match the ground truth. So this is just a little illustration of how it was set up. The participants were provided a web-based system, and if you look in the sort of blowout of the user interface, you see at the top, we have a classification prediction, so either sensitive or not sensitive, and a confidence score of the classifier. And this was set at the top of the screen so that they had to have this, they had to interact with this prediction first before they could actually go and review the documents. So I think I've covered most of the stuff in this slide, but that just shows you the sort of the setup of the batches and the fact that there was a ground truth by expert government reviewers. So how do we evaluate the outcome of the user study? We want to measure reviewer accuracy. So in essence, we're sort of treating the reviewers as a classifier. So we can use classification metrics to see how well the user study participants' judgments match the expert ground truth, reviewers' ground truth. And then we want to measure how quickly they actually review the documents. So we use a measure called normalized processing speed. I won't go into the details too much, but it basically uses geometric averaging to account for the differences in reading speeds across different reviewers and variations in document lengths. Okay, so first hypothesis that we looked into was as the effectiveness of the classifier increases, the classifier will be of more benefit to reviewers, and therefore reviewers will make more correct and less incorrect judgments. Okay, so just looking at the results that we got from our study, on the left-hand plot, as you look at it, shows the accuracy of the reviewers in balanced accuracy, and the right-hand plot just shows the same evaluation, but in terms of F2. So we typically use F2 instead of F1 because it puts more emphasis on recall and identifying, or there's more of a penalty, or it's worse to incorrectly predict or classify or judge a sensitive document as being non-sensitive than it is a non-sensitive document as being sensitive. So if you miss a sensitive document, it gets released into the public, and there's consequences from that. Therefore, we put more emphasis on recall. So the plot shows Cosnew and Morey within subject 95% confidence intervals. So basically non-overlapping intervals show significant non-overlapping intervals of a significance with a p-value of 0.05, and if it's 0.01, and if it overlaps by less than 50%, it's 0.05. So what do we see? Basically, providing the reviewers with classification predictions increased their accuracy compared to the expert judgments. But interestingly, there seems to be diminishing returns, particularly in terms of F2, and where the perfect predictions didn't actually result in significant improvements over or significant with p.01 over the back 0.7 classifier. So providing classification predictions helps. There's still ongoing work looking at how effective does this classifier really need to be in order to help them make accurate decisions. The second thing we want to look at is how quickly they make their decisions. So here we see normalized processing speed for the 3 different classification treatments. Interestingly, back 0.7 results in significant increases, markedly increased, I think it was 72% increase to 260 words per minute. But again, we don't see the same results. We don't see the same increases when we got a perfect classifier. So again, there's an open question as to, once you reach a certain point of assisting these reviewers, how much more effort do you need to put in, or are you better focusing your effort somewhere else? Okay, so once we look at whether it works or not, we want to know, want to look in a wee bit more depth, So there's 4 possible reviewer classifier disagreement outcomes. So the classifier can either say a document is sensitive or not sensitive, and for each of these predictions, a reviewer can either agree or disagree with the classifier's output prediction. So we want to know what's the effect of these different outcomes on the reviewing speed. So interestingly, or maybe not quite so surprisingly, we see that when the reviewers agree with the classifier, it increases their reviewing speed a lot. So here, for sensitive documents where they agree, it's increased by 45 words per minute. For non-sensitive, where they agree, it's increased by 63 words per minute. However, when they disagree with the classifier, that actually reduces their time their reviewing time slightly. Because obviously, you know, if it's non-sensitive and they think it's non-sensitive, it seems to be they can make the decision quite quickly. If it's sensitive and it helps them identify the sensitivity, then it increases. But whenever they sort of disagree or they're not sure about the classifier, it can actually take them a wee bit longer. But overall, we find that it amounts to an overall increase in the reviewing speed. So that just says, you know, when they agree, it works great. We need to maybe have a look to see when to provide so if it's not going to help them, if they're disagreeing with the classifier, maybe we need to look at when we should be giving these predictions. If they're likely to disagree with it, is it actually going to help them? Okay, so basic sort of conclusions. It's the first sort of user study to evaluate the benefits of automatic sensitivity classification for assisting human sensitivity reviewers. We sort of provide strong evidence that sensitivity classification is a viable technology for assisting digital sensitivity review, but not all predictions are of equal benefit. So I think, you know, in all of these areas that we're looking at, you know, we've made improvements, and we are actually managing to assist reviewers, but there's still open questions in all of the areas. And we're finding out an awful lot more of these open questions in our ongoing research and development. So unfortunately, I can't say too much about the details of what we're actually doing in this project, but we are continuing this research, and we are part of a consortium, as was said in the introduction, that are developing the first sort of technology-assisted sensitivity review system for UK government. So we have, as a consortium, actually successfully managed to digital sensitivity review and transfer the first large-scale batch of digital records to the National Archives at the end of last year. But there's an awful lot of ongoing work, and lots of new problems that we are investigating as well. So, for example, we have recently done work on learning entities and entity relations within a joint embedding space, so that we can augment the semantic classification approach that we spoke about earlier on in the project. We've got completely new tasks, such as what we refer to as guidance search. So there are some types of sensitivities that are, or some types of information that whenever these sort of information appears, there's a reasonable chance that it could potentially be sensitive. Therefore, it should be at least critically reviewed. And these exist as sort of profiles of sensitivity. So using these profiles of sensitivities as search queries to try and return the documents in the collection that actually are relevant to those search queries. We are also, like, as I said at the start, you know, all of this is done on large unstructured collections of documents where you don't know anything about the relations between the documents and the information between the documents and what the potential sensitivities are. So we're doing work on automatically producing sort of chronological and coherent stories or threads of information that are made up from different passages within the documents within the collection, so that we can try and automatically sort of regenerate the structure of the collection that would have existed if it was, you know, if it had a reasonable file structure in the first place. Plus, it also enables the reviewers to automatically see all the documents that are related to each other, so they can easily find sensitivities that they may not be aware of if they didn't have information from multiple related documents. We've also got other ongoing work like sort of predicting the reviewing times of reviewers. So for individual documents take different amount of times to review. Therefore, we might want to use different strategies for different types of documents and things like that. So the work that I presented, was the sort of backbone to sort of getting all this up and running, but there's lots of interesting and difficult challenges that we've been encountering along the way after that. So I'll be happy to sort of discuss any of the content of all that in the question session. So thank you.
So thank you very much, Graham, for the wonderful talk. So, I mean, Procheta, who I've introduced you, is not feeling too well. So I have been taken over. Thank you for the wonderful talk. It was really, really interesting. And we already have some questions. So let's take the questions. Doug, I think you are promoted to panelist. So you may ask the question if you want yourself. Please unmute yourself, turn on your video, and feel free to ask.
Okay, very good. Graham, thanks so much for coming and for this great talk. Great to hear what you're up to. You mentioned very briefly mosaicing and maybe switching from trying to find sensitive documents to some other presentation mode, which I don't know, might have involved mosaicing or something else. But I wonder if you could talk about that, if there's anything to say yet about it. I mean, it's a really interesting but really difficult problem.
It certainly is a very interesting and very difficult problem. I think there is some sort of peripheral work going on to be able to sort of help to maybe start to identify these potential sensitivities. So the work that I mentioned briefly at the end, the ongoing work about identifying sort of salient and coherent threads of information, I think is going some way to actually trying to help reviewers at least identify information which is potentially likely to be lead to a mosaicing sensitivity. It's not in itself actually predicting that this is a mosaicing sensitivity yet, but it's putting together bits of information from separate passages in lots of different documents and seeing the relationships between those passages of information and sort of, you can then sort of check to sort of previous historical sensitivities or your categories of sensitivities and things like that and match them up. And then you can get a sort of classification confidence score as to what's the likelihood of a sensitivity existing in these sort of collected pieces of information. So that goes some way towards it. Another approach that I'm aware of, or we've sort of looked at, is just actually doing it from the sort of reverse engineering point of view, where I know there's some people who are looking at it from, now that the data is becoming available and searchable, just having teams of people who use the technologies that are generally available to savvy public, like, Python and things like that, and actually just going and doing it and collecting information about it to try and sort of create a test collection, which can then be used for training classifiers and stuff. But I mean, it's a hugely challenging issue because obviously, identifying sensitivities in one document at a time is context dependent. I imagine it kind of explodes when it goes to putting it together from lots of different documents. So there is ongoing work, and there's existing classification techniques and stuff that could potentially be used for it, but I think it's in its infancy, to be honest.
Very good. I like this idea of the story threading as one step in the right direction. I think that's well motivated. So thank you.
Good, thanks.
Thank you, Doug. So there is another question. Graham, you can read directly from the Q&A, the question by Rahul Bishnoi. So
question
first,
is,
yeah.
Can this model of sensitivity reviewing be applied to sharing of public data of citizens between various departments of the government or their agencies as part of an interdata sharing policy, which can potentially be misused to create 360-degree profiling and so as to secure right to privacy? So I think if I'm interpreting the question correctly, you're saying can this be misused? So in other words, if the processes were in the public domain, could someone use it for existing documents to uncover the privacy of citizens? Sorry if that's not what you meant by your question. Maybe you can clarify, but I suppose any technology has the potential for being used in ways that it wasn't initially intended in being used. The approaches that we've sort of presented in the public are they're based on existing approaches, and they are tailored for specific sensitivities. So the idea being that if our approaches work in conjunction with human reviewers and people do their job, then these sensitivities shouldn't actually be going into the public domain. And the things that we're sort of uncovering are sort of general features of sensitivity, so that the reviewer, the human reviewer, can make the final judgment. So in other words, we're providing assistance with the context and stuff, but it still takes the reviewer to actually make the judgment. So I don't think these particular technologies in the hand, like if they're out in the public, I don't think these particular technologies are particularly likely to uncover, or what is it? I think, sorry, I may have got the question back to front, to be honest. I don't know if you're asking if it can be used to secure the rights of privacy to citizens, in which case it probably could, or if it could be to uncover the rights of citizens. I don't think it's likely to be able to uncover particularly things about citizens unless you've got someone actively looking for things, and in which case it's not tailored at finding specific individuals. It's not tailored.
So Graham, would you like to have a clarification of the question?
Yes, please.
Okay, so can Rahul Bishnoi be elevated to panelist, please? It would be nice if he can ask the question himself. That's the best way, I think.
Yeah, I already gave him the permission to unmute.
Okay. So Mr. Rahul Bishnoi, if you're here, can you please unmute yourself and ask the question? Rahul Bishnoi. Mr. Rahul Bishnoi, are you there?
Yes, he's here, but he's muted.
He's muted. Can you please unmute yourself and please ask the question?
Yeah. Hi, Graham. So
hello, thank you.
Yeah. So my question is pertaining to the reviewing of documents that different agencies of a government have in their individual capacity, that they do different functions. Like a health functionary would have documents about the health state of citizens, or a different agency like tax records have tax information. So in a case where a government decides to share these documents with each other, with each departments of the government, would it be feasible for this model of sensitivity review to weed out all the sensitive information so that all non-sensitive information can only be shared?
That's generally the sort of point of it, but it's a human in the loop process. So it's there to assist human reviewers. So there's definitely documents that pass between different government departments, and that sort of has a knock-on effect that different government departments might be coming to sensitivity review a similar version or the same document and passing it out themselves. So yeah, the processes are quite generic in the fact that they can be adapted to any sort of department, but the active learning strategy is designed to be able to quickly learn from the reviewers what are the particular sensitivities within a particular collection of documents. A collection of documents could be within the same department, or it could be in different departments. So I think the answer to your question is yes, as long as we've got a human in the loop who's actually still doing the final judgment. Does that answer your question?
Yeah. Thank you so much, Graham.
Okay, thank you. Sorry for misinterpreting your question.
So thank you, Mr. Rahul Vishnoi. So I think we have exhausted our quota of 1 hour. So we would like to close this session, and I would request Graham to please join the private session. The link is already with you, and for convenience, I have also pasted it in the chat. If you have, you can view it.
Perfect.
So see you in the private meeting link, and thank you to all the attendees for attending this session, this wonderful session. Thank you very much.
Thank you very much.